Actually, it turned out that of all of the predictors, it was second after knowledge of the prior fall in the prior year. Now, part of the issue was we also evaluated them using a standardized gait and balance assessment, which included full battery, the timed up and go test, etc. I mean, everything that we would typically do. We had that administered by a professional biomechanist who was part of our team. And it turned out that although we were able to find that stride time variability was a good predictor, it turned out we could only get that on about 35 out of the 53 people. So, you look at it and you've got about 2/3 of the folks could do that test, and you're fully missing 1/3 of them who couldn't even generate data because they were too frail. So one of the things that we've got with our measure is that you can get it not only from a person who can ambulate, but also from people who can just use a wheelchair. It turns out that if they're cognitively confused, if you will, from where they are spatially, that they're going to have problems navigating a wheelchair just as much as they are walking, and that also puts them at risk for later falls when they attempt to stand up and walk. And in some cases, you find people use a wheelchair on one day or not others because of, maybe hip pain or joint pain and so forth. So they'll use a wheelchair electively. So what we're seeing is that this can be a very powerful measure. We found that for our group that it was impossible for us to use medication as a predictor because everybody in our sample in the ALFs were on 13 medications on average. There was nobody who was unmedicated. And so trying to back out the effects of medication was also fruitless because you were dealing with, again, people that were potentially at a very high risk. So one of the things that we were also looking at was the degree to which fractal D at various points in time is predicted. So we went back to the individual's fractal D in the first week and looked at that versus when they fell. And what we did find is that the further back in time you went, the less predictive of falls fractal D was. So it's kind of like predicting the weather.
Right.
You can predict reasonably well what the weather's going to be in the next 2 or 3 days. 7 days out, it's not so good. Because about 6 months, you have the long run averages. It's summertime, it's going to rain in Florida. That's kind of okay. It's about a 50-50 odds.
So this is say people get more and more aimless just before a fall?
Yeah, I mean, that seems to be what we're finding. And that the degree of aimlessness, if you will, and the degree of movement variability and randomness that they have is a significant predictor. And when we looked at just the effects of past fall history, I believe the relationship there was about 55% of the variance. I think it may have been a little bit higher than that. Could be attributable to the past fall. But when you added in the fractal D measure, we were able to get about 80% correct classification. So we took a big step when we added that in. So we were very excited about that because this is something that can be gotten just from a transponder as a person moves around. And the transponder tag itself is only about the size of a wristwatch. It has a battery in it that, what essentially it's giving you is the flight path of the person through time. And the actual data that it generates can be broken down into fractal D on a second-by-second basis. In fact, that's what we have generated with a colleague of mine whose name is Jeffrey Craighead, who's a brilliant programmer. And Dr. Craighead has generated a software algorithm, which is called the real-time fractal path algorithm. And what this does is it can actually take the data coming directly off of the tracking system and calculate fractal dimension for the individual as they're moving, and then puts that into a database in real time as the person's moving. So it can do that for, say, 20 or 30 people at a shot simultaneously, so that you collect, an enormous amount of fractal data on large numbers of people at once. And that's really where the economies of scale come in. So now you start looking at this and say, well, okay, the cost of implementation is $10,000 for this generative technology device, but then for each person it's a $50 tag, which you can do cost recovery or however you want to do it. But the downside, ordinarily downside, is that a certain number of these people are going to fall during the year, which is a potential lawsuit on the order of maybe $100,000 a piece. Well, if you can head off one or two of those per year, then you've got a situation where you can wind up saving significant amount of money for the ALF operator, to the point where the system saves more than it costs. And then you get into questions about, how do you accommodate this in terms of insurance premiums and so forth. But when you start looking at it from that point of view, it makes sense, because then you start targeting your care toward the individuals who are showing the highest fractal D, for example. And one of the things that we have yet to really pursue with this, but which I think is implicit in this, is that fractal D can change over time. It doesn't always go down. There are some days where people's fractal Ds will go up from one day to the next, and then some days will go back down. And I think that if you look carefully and assess for delirium, that what you will actually see is that the movement variability, the fractal D that we've been looking at, probably is a covariant of the status, the delirium status for the individual. And that may be linked to other things, such as, for example, a urinary tract infection, for example, or possibly a medication overdose. Now, one of the advantages of the approach we're using is that we have a means of feeding information back to the assisted living facility operator on a regular basis, a daily basis. And you've got a means of feeding that information out to other caregivers as well, so that the same data that the ALF operator gets, which might be, okay, Bill's fractal D today is a 1.35, this is a red flag. You need to check him for, an elevated temperature. Maybe he's got a urinary tract infection. Maybe he's got some other things. But that information can also be sent out over a computer network to the person's electronic health record, so that the person's physician gets a flag that says, Bill's having a rough day, and you put him on a particular blood pressure medication 2 days ago, and his movement variability may be indicative of cognitive problems that have resulted from being put on a new beta blocker, which now is inducing some level of lightheadedness or confusion. So that you can actually see, okay, look, I put the medication on here and his fractal D went up, and so this is putting him at risk for a fall, so I've got to bring it back in and adjust this medication. As opposed to doing it after the guy's in the ER as a result of fooling around with the guy's medication.
Right.
So anyway, sure.
It doesn't crash.